Page 14, number 8, is asking us to find the general Taylor polynomial. Okay, that's our goal. What I'd like to offer is an alternative solution. You can always go and find your derivatives, plugging in c equals 0 as your point. But what I'd like to do is try to see if we can use the one we know. This is the geometric series, and this is true for absolute value of x is less than 1. So let's see if we can use this information to find the expansion for this, rather than taking all the derivatives and plugging in, which you can do. The problem with taking the derivatives and everything is it's going to be difficult to look back and find out what the general equation is. Okay, so the first thing I want to do is get this thing to look like that. So I'm going to rewrite f of x 3x minus 1 over 2x plus 1, that's equal to 3x over 2x plus 1 minus 1 over 2x plus 1. And in order to start matching it up with this, I want to have 1 minus something. So let's rewrite this again. This is going to be 3x times 1 over 1 minus negative 2x minus 1 over 1 minus negative 2x. So these two things here look the same. This is a parentheses here. Apologize for that. It's 3x times this term and then this guy. Okay, so this by itself, if I were to have a negative 2x here, if I write 1 over 1 minus negative 2x, then what I should get is, if I have an x here, I get an x there, so if I have a negative 2x here, I should get a negative 2x there. So this term can be written as negative 2x to the n. And same with this one, 3x times negative 2x to the n. Okay, we're not finished. We'd like to have just one summation, but we've gotten a lot of work done already by writing it this way. Okay, now let's deal with the x. What happens if I have x over 1 minus negative 2x? Well, that's as if I multiplied this by an x. Which all that does is add 1 to the exponent of the x. So this is equal to, let's pull the negative 2. This is negative 2 to the n. And then it's x to the n, but now I have an extra x. So this is x to the n plus 1. Okay, so let's rewrite that. This is equal to 3 times the sum of negative 2 to the n, x to the n plus 1. Minus negative 2 to the n, x to the n. I'm just pulling that negative 2 to the n out here. Okay, so they both have a negative 2 in it. So let's pull that out, let's factor that out in front. And so what I get is negative 2 to the n times 3x to the n plus 1 minus x to the n. Sum that up, and then equals 0 to infinity. that's the solution. If you try to take derivatives and write out the expansion in terms of your derivatives and your factorials, you'll have a harder time coming back and getting this